Hi class, welcome to Unit 1, Day 2 for Math 3. We're going to do a little review of congruent triangles. Now, if you've taken Math 2, you've sure to learn a little bit about congruent triangles last year. If you don't remember, we can do a brief review about it. But basically, with congruent figures, um, two figures are said to be congruent if they have the same size and same shape. Now, triangles are a little bit special because you don't need to know every single thing about them to be able to tell if they're congruent or not. And we have a few shortcuts. Specifically, there's 5 shortcuts that we use to determine if two triangles are congruent to each other. So you'll see 4 on this page. There's 1 on the next page we'll talk about in a few minutes. But these 4 relationships are the congruent triangle theorems. The side is actually a postulate. A postulate is something we just assume. We don't have to really prove it. And so it turns out when you're given two triangles, you don't need to know anything about the angles of the triangles if you know that all 3 pairs of sides have a matching corresponding pair. So you'll see that these 2 pairs of sides have the same markings. They're said to be congruent. So segment AB is congruent to segment DE. And the same thing with AC and FE with the 2 marks and BC and DF. So we would write a congruent statement and say triangle, let me use a different color here, triangle ABC. And order is important. So once I've established that I'm starting with A, B, and C, I want to make sure that I'm starting at the same spot over here. So A is actually going to match up with angle E. If you look at the 2 markings, 1 and 2, A is between them, and so is E. So we say triangle E. B is between the 1 and 3, so we're going to do D. And F would be the last angle in that triangle, last vertex. So triangle ABC is congruent to triangle EDF. That's a congruent statement. And you can break it up in angles and sides if you want. A common way to show side is not necessarily going to be separate, but sometimes you'll see triangles that are or that are sharing a side. For example, you might be given in this picture the fact that this segment is congruent to that segment, or that segment is congruent to that. And you might not have the side in the middle marked, but since they share the side, we know that that itself is a matching congruent pair of sides if those triangles were split apart. So I always mark them. I put the 3 dashes in there, and I can show that these are congruent by side too. Later you'll learn that this is called the reflexive property, which will be used in proofs. And there's other representations of those pictures too. We can talk about the 3 other relationships on this page. Side angle side is a common one. That's when the angle between the 2 sides that we know is congruent to the other angle in that same position in the other triangle. We don't need to know the 3rd pair of sides to be able to say those triangles congruent. This is enough information right there. So in this triangle, I would say triangle QRS is congruent to triangle, and looks like Q and D match up. So D, R is the angle, so we'll do D, E, and F on that one. And some other representations of these figures will come up as we go. A common one that you might see might involve vertical angles, for example. So you might know or be able to figure out these 2 pairs of sides are congruent, but if these aren't marked because they're vertical angles, we should know that vertical angles are congruent anyway. So we go ahead and mark those to show that these 2 triangles are congruent by side angle side. Another one is angle side angle. You'll notice that these are both right angles. They have the box on there, but right angles are congruent. So of course these are going to both be 90 degrees. They're going to be congruent. These 2 angles are congruent, and the mark between the 2 angles on that side is enough information to show that these 2 triangles are congruent. We don't need to know the length of that side or this side or angle T or angle G. That is enough information to show that these 2 triangles are congruent. And the order of that means that there's two angles in the side included, so the S is going to be between, ASA. That congruent statement is going to do triangle ACT is congruent to triangle ODG. And the last one on this page is angle side, and this can be mistaken a lot. A lot of people will mix these two up. Be careful with this one because you'll notice the two A's don't have an S between them. And that's just a way of saying that the side that is congruent to the side in the other triangle is not included in the angle. So it's not connecting the two angles. So N and E doesn't have a slash, C and M doesn't have a slash, but the segment outside does. And you want to be especially careful here because, if this were the one marked, well, guess what? If that weren't there and this were there, they're really not congruent because this is not in the same position as that. You'll notice that this one is on the segment touching the right angle, and this is the one touching the non-right angle. So that one is a little tricky in regards to where the position of that third side is. But nonetheless, showing a congruent statement, it's going to be triangle POM is congruent to triangle, let's see, P doesn't have the marks, so we'll say WEN. And there's lots of different representations of how these look. I will come across these as we go through some of the examples. So let's get into some properties first before we hit up the examples so you can see what we're going to be using when we write up proofs. Oh, I almost forgot. This statement is called hypotenuse leg. This is a special case that is only used in right triangles. So you'll notice there has to be a right angle there. And furthermore, the hypotenuse is the segment that needs to have the corresponding pairs of sides marked. Okay, so you have to have a leg. A leg is one of the shorter segments, and the hypotenuse has to be marked. But if you had something like this, where a leg was marked and another pair of legs were marked, well, those two triangles would be congruent, but not by HL, not by hypotenuse leg. They'd be congruent by side angle side because the right angle is between the two sides. You'll notice it's not between the two sides here. So this is a special case because normally, SSA, if you look at the letters and the sides and angles, that's what you see. That is not really a legitimate reason why triangles are congruent. But if it is a right triangle, it is. We just call it HL or hypotenuse leg. So this is SAS. So let's talk about this example here. We want to know how the two triangles are congruent and give a congruent statement. So you'll notice that we don't have enough information written on here to be able to say, is it SAS, SSS, ASA, or AAS, or HL. But what we can do is say, all right, I got these two pairs of angles. They're both 24 degrees. I know they're congruent. I have these segments here that are marked congruent. So I have a pair of sides, but I don't have any other sides marked, and I surely can't just put a slash in here without any regard to the fact that they're not told they're being congruent or they're not told that this is in the middle. So I can't put a slash there and there. But I do know that these are vertical angles. And although it's not going to be marked on your diagram, we know that vertical angles have the same measure. So we do put a little angle symbol there. I'm going to put two curves because I already put one for the 24s. So in this diagram, I have two angles marked in each triangle, and I have a side marked in each triangle. But the side is not connecting the two angles. It's not between them. It's not included. So I know there's going to be two A's, but the A's are going to be next to each other. The S will be on the outside because it's not the included side. So these are related by angle, angle, side. And the congruent statement is going to be triangle. Let me start at the top, BAC. It doesn't matter what order you start with, but it does matter what order you use on the second triangle. So if I'm using angle B, I need to use angle D because that is the angle that corresponds with angle B. Angle A is going to match up with E. And so by default, we have DEC is the last angle. That's your congruent statement. This is the reason. This is how, okay? So this is your how. Let me write that on here. And this is congruent statement. Let's look at another example. In this diagram, we have a right triangle here. Now, it doesn't have a right angle there, but since that's a straight line, we know a straight line is 180 degrees. This is going to have to be a right angle as well. So I do have a matching pair of angles. Because these are right, they're going to be congruent. They count. I don't have any other angles. I'm not going to mark angles up here. They're not vertical. So there's not enough information to say these are congruent. But I do know that these are congruent to each other, these sides. So I do have a pair of sides, and they share a side. I always mark the shared side. That's called the reflexive property. And I have a right triangle with the hypotenuse marked in each right triangle and the leg that's shared, which I went ahead and marked. So they're going to be congruent by how is going to be HL. That's hypotenuse leg. The congruent statement, let's see if I start with O, OPN, so triangle OPN, that's going to be congruent to triangle O will match up with M. So it's going to go MPN. It's going to be nice and symmetric. So this is kind of your double part answer. You got your how and your congruent statement. All right, next example. All right, these arrows on this triangle represent parallel lines. They don't count as a congruent pair of sides, although we'll find out that they are congruent later. But for now, all we know is these are parallel, okay? From parallel lines, we almost always are going to use the fact that alternate interior angles are congruent. So these angles right here, at the top of angle R, QRT, and STR are considered alternate interior angles. And we can mark those congruent because we know that between two parallel lines, two angles that are alternate interior have the same measure. So these are going to be congruent to each other. We also have the pair of angles here that were already marked. And of course, the reflexive property, the shared side. That's your only side. So there's only one S in this diagram. And there's two angles. And the side that's marked in each triangle is not between the two angles. It's off to the side. So these are going to be congruent by angle, angle, side. And your congruent statement, if I start with, let's say, T, so TQR, that's going to be congruent to angle T in this diagram actually matches up with angle R in this triangle. So this is going to be R. Q matches up with S, and T matches up with R. So this is a rotated around. So these are a little, you got to be careful because don't assume the T is going to be here and the R is going to be here, just because they're in the same spot in the first triangle. All right, the next video we'll talk about properties and definitions, and we'll get into proofs, but I'm going to cut this video off now so you can practice just showing triangles that are congruent to each other based on which reason and giving a congruent statement in your day 2 assignment. So check the next video out for proofs.